Hey guys, and welcome to the school station. Today's video is going to be about electronic structure. This is from the AQA GCSE Chemistry 91 paper from the unit Atoms, Bonding and Moles. Today's video I'm going to be talking about the electronic structure and what are energy levels or energy shells. At the same time, we're also going to be talking about maximum amount of electrons you can hold in each shell and also similarities to spot between the periods and groups and the elements. So I really hope you guys enjoy this video and I hope this helps you, and let's just get right into it. So first of all, you guys may have already seen this, but this is actually the structure of an atom. So obviously we know that the atom is not the smallest thing that there is in the world, because atom also has subatomic particles. We obviously know that there is actually protons and neutrons in the nucleus, which is actually in the middle of the atom. And there is also shells orbiting the nucleus, and in the shells there are also electrons. So after we actually know about the structure of an atom, we also have to think about the energy levels and shells. So we can see that there are actually these shells over here, but are there actually any order or any way of calling the shells, like any names? Because do we just call this like the first shell and the second shell, or like how do we really classify or name these shells? Well, you have to know that these are actually called energy levels as well, and you have to know that the lowest energy level is the orbit or shell nearest to the nucleus. So obviously this circle or this shell over here is nearest to the nucleus, and this is going to be called the lowest energy level. So in the exam, if they says that how many electrons are there in the lowest energy level, they're talking about the shell nearest to the nucleus. And then we also have the highest energy level. So obviously there can be many energy levels in an element. There can be 4, there can be 2, there can be 5. So you have to really look at the highest energy level, and the highest energy level is the one that is the furthest away to the nucleus. So over here in this example, this one is obviously the one furthest away from the nucleus, so this is going to be called the highest energy level. But if there was another one around this energy level, if there was another one if there was another third shell, then that would be the highest energy level, because that would be farthest away from the nucleus. So whichever shell is farthest away from the nucleus, that is going to be called the highest energy level. So now that we've actually talked about the lowest energy level and the highest energy level, and you should be able to identify these in your exam, now we actually have to talk about the maximum amount of electrons in each shell. So we have to really think about obviously the first shell, second shell, third shell, fourth shell, but we also have to think about how many electrons can each shell hold. It's just kind of think of it as like maybe let's say a basket, okay? So maybe the first basket is very small, so it can hold up only 2 electrons, okay? So that's going to be the first shell. The first shell is obviously the one nearest to the nucleus, and this is actually going to be can only hold up 2 electrons, because obviously it's very small. And yeah, you just have to know that in any element there is, if you're going to have to draw the electronic structure, the first shell can only hold 2 electrons, as shown in this example over here. The second shell can hold up to 8 electrons. So again, if you're drawing, let's say, I don't know, an element that has 10 electrons, you would have to actually draw the first shell's 2 electrons, and then you can't draw more electrons in the first shell. You have to go straight to the second shell, because the first shell can only hold up to 2 electrons, and then you go to the second shell and you draw 8 more electrons. If let's say they tell you that no, there's 11 electrons, then you can't add one more electron in the second shell. You have to go straight to the third shell, because the second shell can only hold up to 8 electrons. You can't just put 9 electrons in the second shell. The third shell can hold again up to 8 electrons, and the fourth shell can hold up to 18 electrons. So just kind of think of it as maybe a basket. So the first basket can only hold up to 2 electrons. If you put more, maybe the shell is going to break, so the basket is going to break. So just kind of think of it like that. And even for the fourth shell, the fourth basket is really, really big, but it can only hold up to 18 electrons. If you put one more, then the fourth basket is going to break. So just kind of think of it like some baskets holding up some electrons. So that's what I would really recommend you guys. And over here is an electronic configuration. So an electronic configuration is basically just representing what you have drawn into a mathematical form. So over here you guys can see, as I said over here, there is two electrons in the lowest energy level, and then there is 4 electrons in the second shell. So as you guys can see, overall there is altogether a there are 6 electrons in this atom. So the way you can actually represent this using an electronic configuration is to just say 2, 4. And just like how we put over here in brackets, we can just put 2, 4. And the reason why is because you just basically have to say how many are there in the first shell, you just put 2, and then in the second shell there's 4, so you just put 4. So you basically just go on like that. You just say how many there are in the shell and just write it down next to it. So that's basically how you would do it. So now that we've understood about the electronic configuration and how many electrons can be held up in each shell, remember you also have to memorize those. We have to think about the electronic configuration for the first 20 elements. So this is something that you may do in class. We're basically going to have to learn the electronic configuration for the first 20 elements. So over here I have the first 20 elements and how you would basically draw each of them. So for example, for hydrogen, this is the nucleus. This black dot over here is the nucleus, and around it is the energy level, and we only have 1 electron because hydrogen only has 1 electron, or one, and you will see that in the atomic number it's 1 because there is only 1 electron. And the second element in the periodic table is helium, so it has 2 electrons, and again we would draw that. However, for lithium we don't just draw 3 electrons in this in the first energy level. We have to draw another circle around it and draw one electron, because again, as I said, the first energy level can only hold up to 2 electrons. You can't add 1 more. So if you want to draw the third electron in lithium, we have to draw another shell and just put 1 electron. So you just have to keep carrying on like that. So I want you guys to maybe like pause this video and try to draw the elements. I know it's going to be really time consuming, but you should try drawing the electronic structure and writing down the electronic configuration for the first 20 elements in the periodic table. And this is something that could definitely come up in your exam. So definitely pause this video and try to practice these, because it will really help you to understand how many electrons you can put in each shell, and you can mark your answers using this diagram over here. Alright guys, I hope you guys do try this out in your spare time. I know it's going to be time consuming, but it will definitely help you. But just before we actually end this video, I want you guys to also spot some similarities. So if you guys can see over here, we actually have groups and periods. So we probably should have learned this in the periodic table. There are actually groups. So there is group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8, and there is also periods. So these are the elements across a period. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. This is in the period 2. So this is the period 2. And also, let's say helium, neon, and argon. These are in group 0. Okay? So you basically just have to categorize them. So if you was to say what period a group neon is in group 0 and period 2. So that's how you basically say it. So now that we've actually understood about the periodic groups, we actually have to spot some similarities between the groups and the periods and its electronic structure. So if you see over here, there is actually the elements in each group have the same number of electrons for their outer shell. So let's look over here. So we have, let's say, group 4. We can see that in carbon, there is actually the electronic configuration is 2, 4, and for silicon, it's 2, 8, 4. So we can see that for carbon and silicon, they're both in group 4, and they also have the same number of electrons in their outer shell, because even though silicon has an extra shell, it still has 4 as the last number, and also for carbon, it also has the last number as 4, and they're also in group 4. So the similarity spot over here is that the elements in each group have the same number of electrons for their outer shell. Okay, and also for secondly, we also have to say that the elements in each period have the same number of energy shells. For example, period 2 has 2 energy shells. So again, as you guys can see, period 2, we can see that there is always 2 shells over here. Okay, just go through the whole of period 2, we can see that there is only 2 shells. When it comes to period 3, you can see that they all have 3 shells. When it comes to period 4, they all have 4 shells. So you just can basically understand that all of them have the same amount of shells. So that's basically the similarities you have to spot. So I hope you guys will actually enjoy this video, and I hope that this helps you. Just an overview of what we have learned today. Number one, we have learned the difference between a low and a high energy level. So obviously, again, we can see over here that the lowest energy level is the orbit or shell nearest to the nucleus, and the highest energy level is the one farthest away from the nucleus. We also have learned the maximum amount of electrons the first four shells can hold, which you should definitely try to memorize. You could just memorize it by saying 2, 8, 8, 18, because that will just tell you how many electrons can be held in each shell for the first four shells. Number 3, we also learned the electronic configurations and structures for the first 20 elements in the periodic table. This is something you should definitely try doing at home. And number 4, we also learned the similarities between elements in a group and elements in a period, because obviously in a group there is, let's say over here we have the similarities over here is that there is obviously the same number. So we have, let's say 2, this excluding this, we have 8 and then 8 again as the last number. And for periods, we obviously have the same number of shells throughout the whole period. So that's basically everything we have learned today. I hope you guys enjoyed this video, and I hope this helps you. Definitely give this video a thumbs up and subscribe to the school station for more free science and maths lessons. Bye guys!